Hey kids, so you know I've been struggling with overriding the equals method, and I really didn't like how code.org handled it, so again I've been doing some research on this, and here's what I've come up with. So let me explain it using this demo class and this associated dog class. So the dog class has three instance variables: a name, a breed, and an age. And I did not use any access modifiers, so there is no private in front of these because I did not want to use a getter method to access those instance variables. Here is the constructor, and down here commented out is the equals method that I override, but we'll come back and talk about this in a second. So let's go back to the demo class. And in the demo class, I have created three dog objects. The first dog and the second dog are both dog objects that have the same name. Both of them are named Tonka. The same breed. Both of them are pit bulls. And the same age. Both are 8. So I think if you asked anyone, those two objects, first dog and second dog, are actually describing the same dog. The third dog has just been set equal to the first dog. And so what I'm interested in is what happens when we run this and we compare the different equals methods. So I am going to compare here. I am going to compare whether the first dog is equal to the second dog, and then I'm going to compare whether the first dog is equal to the third dog. And we'll actually try this in a couple of different ways down here in the bottom. So we will compare the first dog to the third dog using equal, first dog to third dog using the dot equals, and then we'll also compare all three of their memory locations. So let's give this a run. And so this first statement is this, printing out whether the first dog is dot equal to the second dog. That returns false. And since this returns false, the else statement is executed, so 1 and 2 are not the same dog. So that's what it says there. So now we check if the first dog is equal to the third dog. The dot equals method returns true. That makes sense. So 1 and 3 are the same dog. When I go down here, both of those statements return true. So it doesn't matter if I am using the equals method or the dot equals method. And you'll notice when I print out the first dog and third dog, these are the memory locations. So the dog object is at, and this is a hexadecimal memory location, and both the first dog and the third dog are returning the exact same memory location. So those two objects, those dog objects, are pointing at the same place. However, the second dog is not. The second dog is pointing to someplace different, which is why 1 and 2 are not considered to be the same dog. So what we would like to do is we would like to override the equals method and compare the instance variables. And so I'm going to go over here to the dog class, and I'm going to uncomment out this equals method. So it's important that the method signature looks like this. Public Boolean equals object with a capital O, other, because this method belongs to the object class, which is the mother of all classes. And then what I do is I start out by declaring a dog object, other dog, which is simply the other dog that's being passed to this equals method, it's being cast as a dog. I need to cast it as my dog to see if it has the same instance variables as my dog objects do. And so the first thing I do is I take this current object that I have and I check to see if its name is equal to the name of the other dog. And I need to use dot equals here because these are strings. And so I need to compare strings using the dot equals method, and that dot equals method resides in the string class. But then I negated it because if they are equal, I don't want to return false. So if they are equal, I skip this, but if they are not equal, I would return false. Then I check their breed. This current object, the breed, does it equal the breed of the other dog? And again, I'm using the dot equals method because the breed is a string, and the dot equals comes from the string class. And the same logic, if the breeds are the same, then I negate it, which is false, so it would skip the return false. If they're not the same, if the breed is not the same as the other dog, then doing not would return false. And then I compare the age. Is the age not equal to the age of the other dog? If that happens to be a true statement, I'm going to return false. If they are the same ages, I'm going to skip this. And if none of these return statements are executed, I'm going to come down here and just return true. But as soon as I return something, I pop out of this method. I don't need to mess with it. So let's go run this method again and see what happens. So notice the dot equal methods for comparing the first dog and the second dog. It returns true and it considers 1 and 2 the same dog. It has not changed for the first and the third dog. So 1 and 3 are still the same dog. However, notice that the memory state locations haven't changed for the first and third dog, nor has it changed for the second dog. What I've done is I've just overridden it to check their instance variables. I'm really comparing the instance variables to see, are they really the same thing? Now, what if I changed in the second dog, what if I changed 8 to 7? And let's run it and see what happens. So now the first and second dog are not the same dog. Now they're different dogs. Let me change that back to 8, and let me take out the space in Pitbull. I run that. And the first and second dog are not the same dog because remember, Java is case sensitive and space sensitive, so Pitbull with the space is different from Pitbull with no space. And suppose I use a lowercase t for the name and run that. Again, the first dog and the second dog are not considered the same dog. So by overriding the equals method, we are essentially just trying to set it up so we can compare each of the corresponding instance variables. And we are checking if the instance variables are the same. And logic would dictate that if the instance variables are the same, then the two objects are also the same. Anyway, I hope this makes sense and we can talk about this more this week.